All right, section 9.1, we're going to be solving trig equations with identities. So basically, what this is saying is we're going to be using a little bit of college algebra basics to help us solve for trig identities. And there's honestly a bunch of different ways you can write a trig identity. So what we're going to do is we're going to start with the more complicated side, and then we're going to work with that to rewrite the expression until it's transformed into the same expression on the other side of the equation. That would say that we are verifying the trig identity. Now we're going to be using Pythagorean identities, even and odd identities, reciprocal identities, and quotient identities, all of these. So all of these identities are going to be used in verifying trig equations. So the students usually run into issues with this section because there's a lot of different ways you can work these problems. And so I would really focus on verifying these trig identities and really using each of these identities here. Okay, so let's look at this one. If we're going to verify that cotangent of theta over cosecant theta is equal to cosine of theta, well, we're going to start with a more complicated side, which would be this side right here. So the first thing I'm going to do is I'm going to separate them. Because notice if I multiply them together, this would come back to cotangent of theta over cosecant of theta. Okay, so I'm just going to separate them out. And then I know that 1 over cosecant of theta is the same thing as sine. And I know that cotangent of theta is the same thing as cosine over sine. So I'm going to replace those. Cosine over sine for cotangent times sine. And I'm going to put this over 1 just to represent that sine is in the numerator. Now notice I've got a sine in the top and the bottom here, so I'm going to cancel those out, and I'm left with cosine of theta, which is what we were trying to verify. So we took the more complicated sign and we used our identities, and we got it down to what the other side of the equation is. So we have verified this identity. Okay, if we look at this one, verify 1 minus sine squared of beta over cosine of beta is equal to cosine of beta. We'll start with a more complicated side, and this is definitely the more complicated side. Now, I want to take a look at this right here. Now that looks a lot like our identity of sine squared of theta or beta plus cosine squared of beta is equal to 1. Now if I move sine squared of beta to the other side, well, I get cosine squared of beta is 1 minus sine squared of beta, which, look, these two things are exactly the same. So I could replace that with cosine squared of beta. So I'm going to go ahead and do that. Okay, so go ahead and put this over cosine of beta. So top part is cosine squared of beta. Bottom is cosine of beta. Now this 2 is just notation. You could write this as cosine beta in this entire thing squared over cosine, which then you could write this as cosine beta times cosine beta over cosine beta. So I can cancel cosine beta out, and I'm left with cosine beta, which is the other side of the equation. So this is also verified. Okay, look at this one right here. So cosine squared of theta times tangent squared of theta plus 1 is equal to 1. More complicated side, definitely that one right there. Now notice I have a tangent squared of theta plus 1. That looks an awful lot like 1 plus tangent of theta squared is equal to secant squared. I'm just coming back, let's see, here to my Pythagorean identity. Okay, so this whole thing right here is equal to secant squared, which is this part right here. So I'm going to replace that with secant squared. So cosine squared of theta times secant squared of theta. Now I can write, we know that secant of theta is 1 over cosine theta. If I square this, I have to square the other side. So this would be secant squared of theta is equal to 1 over cosine squared of theta. Okay, so I'm going to replace this with this part right here. So cosine squared of theta times 1 over cosine squared of theta. I'm going to put this over 1 just to represent the cosine squared is in the numerator. Well, notice they cancel out, and I'm left with a bunch of 1's everywhere. So this is equal to 1, which is the other side of the equation. So we have verified that this identity here is an actual identity. Okay, if we take a look at this one. Cosine of alpha over secant of alpha plus sine of alpha over cosecant of alpha is equal to secant squared of alpha minus tangent squared of alpha. Well, I would say that the fractions would be the more complicated side, so we're going to start with that one right there. So if we've got cosine of alpha over secant of alpha plus sine of alpha over cosecant of alpha. Now, what I need to do is, first of all, I'm going to separate them out. So cosine times 1 over secant of alpha plus sine of alpha times 1 over cosecant of alpha. Now we know that 1 over secant of alpha is the same thing as cosine. So we've got cosine of alpha times cosine of alpha plus sine of alpha. And then we know that 1 over cosecant of alpha is sine of alpha. So I've got cosecant squared of alpha plus sine squared of alpha. But that's not what I'm trying to get. I'm trying to get this over here. By the Pythagorean identity, let me get back to it right here. We know that this is equal to 1. So I'm going to set it equal to 1. Keep this one in mind for right now. Okay, so this is equal to 1. Okay, but that's what I'm not trying to get that. I said hang on to that other Pythagorean identity. This one right here. This one has all the parts needed for this one. It's just a little bit different. So say I move the tangent over to the other side. So I subtract tangent from both sides. Well, hey, 1 is now equal to secant squared of alpha minus tangent squared of alpha, which we have a 1 right here. So this is actually equal to secant squared of alpha minus tangent squared of alpha, which is the other side of the equation. So we have verified this identity right here. Now let's take a look at this one. 1 over 1 minus sine of gamma plus 1 over 1 plus sine of gamma is equal to 2 secant squared of gamma. Okay, so I'm going to take the more complicated side, which is definitely this one right here. So 1 over 1 minus sine of gamma plus 1 over 1 plus sine of gamma. Oops, those look like alphas. Okay. Now what I'm going to try to do is to get the denominators the same. So the least common denominator for these two is really just multiply them together. That's a LCD. So what I need to do is for this one, it's missing the 1 plus sine of gamma, so I'm going to multiply the top and bottom by 1 plus sine of gamma. This one's missing the 1 minus sine of gamma, so I'll multiply that one, the top and the bottom, by 1 minus sine of gamma. Okay, like this right here. So now I've got 1 plus sine of gamma over 1 minus sine of gamma times 1 plus sine of gamma plus 1 minus sine of gamma over 1 plus sine of gamma 1 minus sine of gamma. Okay, so now I can combine the numerators together and I will get 1 plus sine plus 1 minus sine all over that LCD. Okay, so I have a sine cancel, and then 1 plus 1 now give me 2. So let me come over here. So 2 over, and then I'm going to multiply these out. So this is going to give me 1 times 1. You can full it out. 1. 1 times sine, so plus sine. And then negative sine times 1 minus sine. And then negative sine squared, running out of room there. My sines go away. So I have 1 plus, or sorry, minus sine squared. Okay. Now remember, we've already looked at 1 minus sine squared. That was at, not this point. At this point right here, we'd already said that that's the same thing as cosine squared. So I'm going to go ahead and replace that with 2 over cosine squared. And if I separate these out, 2 times 1 over cosine squared, well, 1 over cosine squared, that's the same thing as 2 secant squared, which that is the same thing as the other side of the equation. So we have verified this identity.